deep learning topic 13. Okay, so if you open the 13th topic, okay, I didn't write this slide. Okay, this slide is provided by, I think it's MIT. Okay, MIT. So it has a lecture on deep learning basics. So I just simply copy its slide. Okay, so it's right on here and on here. And my recommendation is that I will talk about some basic concept and theory, why we can use deep learning to do classification, to do clustering and something like that. And after that, okay, please take a look at this, I think it's YouTube video. Okay, they have a 1 hour introduction and overview to deep learning, and it is I think the content is a little bit broad, not in depth. So I think you can take 1 hour to take a look at this video to make sure you know the whole picture of deep learning. It's including some regression example, okay, and classification example, and teach you how to classify handwriting numbers. And then at the end of the video, they will talk about how to do language processing. Okay, so it is a broad discussion and introduction to deep learning, and some topic we will review them in the following class. But I think you should take a look at this 1 hour video. Okay, before we continue. This course is provided by MIT when they teach students how to write a self-driving cars. So before you design a self-driving car, you have to analyze the images that a camera can see. So you know when to stop your car, when to turn left, to turn right, and something like that. So before they do the self-driving car, okay, they have to analyze the camera, the pictures captured by the camera. Okay, so they use neural network to do so. So make sure you take a look at this one. But I will use this slide. Okay. So let's go back to the slide, and I will tell you something about why can we use neural network and what is neural network. Okay. So take a look at this one. Okay. So usually the first task, okay, we encounter is a regression, right? We'll talk about it many times. Okay. So usually when we talk about regression, okay, we still draw this table. Okay. We have a lot of training data. All right. And we have a lot of different features. Okay. And for regression, okay, the target value y, it is a real number, right? Well, we'd like to know the relationship between x and y. Okay. Okay. In the real world, when we collect those data sets, okay, usually, okay, I say usually, we partition them into 3 different parts. Okay, in the previous class, okay, we say we partition the data into 2 parts, which is the training data and testing data, right? However, in most of the neural network, when we do the analysis, okay, we require to have another data set, okay, which is called validation data set. Okay, data set. This data set, usually you can now mix these three different data sets. Okay, you collect the data and you partition them into three different parts. Use the training data to train your model. Okay, use the validation data to make sure your model is good enough, and use testing data to verify your for example your accuracy, your MSE value, your mean squared error value. Okay, we use a very simple regression model. Okay, which is y ax plus b. Okay, that is the simplest one regression model, right? But usually, okay, we can write it in this way. Okay, we use another notation. Okay, w1 x1, w2 x2, which is the weight, right? Something like that. Okay, that is a more general form of regression. Okay. When we talk about neural network, okay, if we use the neural network to describe this regression problem, it will be like that. Okay, I have a bigger one. Okay, we have a lot of different input. For example, x1, x2, x3 to xn. Okay, those information that we can observe. Okay, we can collect from those information, right? So next part is I would like to predict y. So here is the y. Okay, and what is the how do we draw this specific model? Okay, that is for example that's model 1, that is model 2. How do we draw model 2? Okay, usually, okay, we connected them by this way, and we write the weight right here. And of course, okay, sometimes you have to, but don't forget that you have one more node right here. Okay, we simply just write 1 right here, or b. So y equals x1 times w1 plus x2 w2 blah 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 to the n, xn times wn plus b, right? If we write this in this way. So that is if we use neural network, which means a lot of different neurons. Those neurons have different functions. They can receive information. For example, y can receive the information from the previous neuron, which is x1, x2 to xn and 1. Okay, and they can process this information. Okay, and they have weight, so that for neuron y, okay, they have different weight. Okay, so maybe the information from x1 is more important than x2, so maybe the weight w1 is larger than w2. Or maybe some information, for example x3, maybe this x3 is useless, so the weight w3 is 0, so that y receive no information from x3. So there will be a lot of different combination by using this. Okay, but for neural network, that is too simple, right? So we have another important things we have to mention right here is that there is a very useful mechanism in neural network. Okay, why do we design such kind of mechanism? This is called activation function. Activation function. Okay, that means after y receive the information from the previous x, and they process it by using the weight, and they do the summation, right? So after y output its value, before y outputs the value to maybe the next neuron, okay, y there is a activation function has been it should be applied to the value, the output value. Okay, so there's a basic question is that, do you believe our world, okay, is linear or non-linear? Okay, I would like to ask the student right here. Okay, 同学们，你觉得这个世界是线性的还是非线性的？这个很难讲，对不对？比如说，我们有时候会觉得身高跟体重好像蛮线性的嘛，对吧？你越高，可能就越重，但是总有例外，没有错了哈。我们说平均而言，那你觉得，比如说你的你的大学的成绩跟你的以后的薪水，到底是线性的还是非线性的？有成比例吗？我们通常会这样子啊，我们通常是觉得说，我们好像有很多东西是线性的，可是如果我们可以用非线性的方式去描述不同值之间的关系的话，或许会更好。因为在非线性里面，我们可以把它简化成线性嘛，对不对？所以如果我们在 model 一个问题的时候，比如说这个问题就是 x 跟 y 嘛，很简单嘛。那我们可能先把它 model 成非线性的会比较好。那如果这个非线性会退化成线性的话，那没有问题。好，所以我们通常在描述一个模型的时候啊，我们在 neural network 里面呢，他们加了一个很特别的式子叫 activation function， 是希望我们可以描述 x1 到 xn 还有那个 b 的关系，除了原本的多项式的相加之外，就 polynomial 相加之外，能够再增加一个非线性的关系，可以吗？啊，这个是我们的想法，它的起源就是我们觉得这个世界很有可能是非线性的组合。好，我用英文再讲遍了哈。Okay, what I said is that we generally believe that our real world is non-linear. The relationship between, for example, your age, your weight, your height, your score, your salary, your something like that. We generally believe, okay, our world is non-linear. So when we design our model, for example, M2, that is a linear combination. That's a polynomial representation of x1 to xn to b, right? We use a polynomial formula to describe the relationship between x and y by using this linear formula, this linear form, right? However, usually we think, okay, maybe this model, okay, model 3, okay, maybe we can write it in this way, okay? We use a big A, okay? Big A is an activation function, right? So we write it in this way. Okay? And usually, okay, mathematicians, okay, they design a lot of different nonlinear function, okay, which is A right here, which is the big A right here, okay, so that we can use this big A to describe the nonlinear relationship between between y and x, okay, and let's go back to right here, okay. So in this topic, okay, we can first take a look at this one, this Wikipedia, okay, this Wikipedia article, okay, which is activation function, okay. So in our model, okay, in our model, the activation function, okay, let's see the definition. The activation function of a node defines the output of the node given an input which is x, right, or a set of input which is x1 to xn and b, okay. So basically we can design several different activation functions. So there is a list right here which is quite good, so make sure you know Wikipedia provides such kind of useful information, okay. So you simply just take a look at this one. Okay, let's take a look at the third one, okay. The third activation function is called logistic or sigmoid or soft step. Okay, the shape of this one looks like this. Okay, we have taught this specific function before when we talk about logistic regression, because the Z shape of logistic regression is exactly the same as this one. Okay, x, okay, sigmoid function equals to 1 over 1 plus e power minus x. Okay, so sigmoid function, okay, its output range is between 0 and 1, which means no matter what information received by your Y node, okay, then your Y node will calculate, okay, its sigmoid value, and the value will be between 0 and 1. Okay, let's take a look at okay, let's say, okay, activation function. Okay, the first one is sigmoid function. Okay, the first one is that. Okay, it looks like this. Okay, that is your input, right? Input, that is your output. Okay, the range is between 0 and 1, and the shape, okay, let's take a look at this one. The shape is like this one, so it will pass maybe I can draw it in this way, which is more clear. Should look like this. This shape will pass 0.5 right here, and sorry, I draw it again. Okay. Okay, so the information received by Y, which is x, right, and including its weight, okay, will pass this function when Y output. So where there is the output, this value. Okay, so the number will be squeezed. The value, okay, the value will squeeze between 0 and 1. Okay, that's one of the way we describe a nonlinear relationship. Okay, that's one of the way. Although we don't know in real world, okay, in real world, we don't know if the height and the your weight, okay, if we believe your height and your weight, the relationship is nonlinear. But actually, we don't know if the nonlinear can be described by sigmoid or by any other activation function. We don't know, but we can try it. Okay, there are several other activation functions, and I think you should just take a look at them. Okay, some of them, like this one, ReLU, ReLU. Okay, this one, ReLU, this one. Okay, you can see that it's a very special activation function. Okay, it says, okay, if the input value less than or equal to 0, the output value is 0, right? And if x larger than 0, and you simply just output x for your input value. So that's a little bit different, a little bit strange, right? So that is sigmoid, and we say ReLU. ReLU looks like this: input, output. Okay, so it's right here. Okay. Make it wider. ReLU means we ignore all the information received by the previous node if it is negative. So the weight, the information if is negative, which means we don't want to pass this information. We don't want to receive. We don't want to pass this information to the other nodes. Okay. Of course, there are certain activation function we'll talk about later. Okay, you can just take a look at these two, which is good enough. Okay, so the next one we'd like to topic is the complex structure. Okay, as we can see, M2 or M3. Okay, we can draw this figure, right? X1 and Y. But usually, okay, when we design a model, a neural network model, okay, we do this way. We have different input value, which is from your data set, right? Okay, we just ignore B, okay, which is more convenient, okay? And we have a Y right here, okay? We can have a lot of different, we say, layers. And the name is hidden layers. For example, I can have another hidden layer right here. For example, H1, H2, H3, H4. That means the relationship between X and Y is so complex, so I cannot use a very simple polynomial form plus and nonlinear activation function to describe such kind of relationship. So maybe I can set up a lot of different layers, and for each layers there are a lot of different neurons. Neurons receive information from the previous layer, such like this one. Oh, in this case, maybe we have to write it in this way. Sorry. Again, okay, write it again. W11 means the weight between X1 and H1. Okay. W21 means the weight between X2 and H1, and so on and so forth. Okay. Okay. That is the first neuron of your hidden layer, right? And okay, let's just design two neurons right here, okay, in this layer, okay? And for this hidden layer, okay, it has second neurons, which is S2. So maybe, okay, you still have a weight right here, okay? W1, 2, right? W2, 2, 2, and so on and so forth. Okay, what exactly this neuron means? That means this neuron has different perspective, or we say this neuron has different point of views to observe, to receive the information from the previous layer, which is X. 好，中文讲遍了哈。我们在这边设计两个 neuron 的意思是说，我们创造两个不同的观点，或是观点的 point of view 哈。这两个不同的观点呢，会视输入的 X 呢以不同的方式。什么叫做以不同的方式呢？就是设定不同的权重，就是蓝色的那一群跟绿色的那一群。好。有时候我们会觉得那些隐藏的关系不是像前面这样讲那么 straightforward 哈，就是 W 乘上 X， 然后就和，然后就带过 activation function。我们觉得 X 跟 Y 之间的关系是错综复杂的。这个错综复杂呢，还包含了我们可以有不同的观点。所以每个 neuron 可以讲说，它 receive 到前面不同的值之后，采取不同的观点，也就是 weight 来解读前面传过来的讯息。所以这时候 H1 跟 H2 就有两个不同的观点，而这两个不同观点的综合呢，或许可以再影响 Y， 好，就我等下后面要讲。OK， So I say here H1 and H2 are two different points of view to receive the information passed from the X layer to this hidden layer. Okay, and further, those information, those received information, okay, they will of course will pass activation function, okay, but which activation function should be selected? We will talk it about later, okay, and further after that, okay, we can further pass the information. We can pass the information from different perspective to Y, and of course there's another way. W 1, 2, for example 3, just simply use 3 and 4. Okay? We can pass different perspective, different point of view from those hidden nodes, and we make a conclusion of Y by using two different weights, W3 and W4, something like that. Okay, so that is, we believe such kind of very simple concept, they can create a very complex neural network structure. For example, you may have 100 layers, and for each layers we have another 100 neurons in each layer. So we have 100 point of view in each layer, and we pass this information through the entire 100 layers from X to Y, so that we can use those point of view, okay, to describe the relationship between X and Y. Okay, I think that is the basic thing you need to know about neural network. Okay, we stop right here, and please come back in 10:15. Okay, 10:15.